to start with our lesson on topics 10 and 11 for Science 9 electricity unit. So topic 10 is measuring electric power and figuring out the cost of that. And then topic 11 is efficiency. I'm going to do all the notes, hopefully as one big package. You guys should have picked this up from school before spring break when you were getting your stuff. So you should have a copy of this. We've also posted a blank copy in case you didn't get one, so you can print it out and follow along. So we're going to start with measuring electric power. So electric power describes the amount of electric energy that is converted into other forms of energy. So whether that's heat or light or motion, sound, whatever the appliance is doing. So that's how much energy is converted per second. So we represent power with the symbol P. So that's what goes into our actual equation is the P. Mathematically, we can define power like this. So power is equal to energy divided by time, okay? We know that energy has the unit of joules, and we know that time, generally when we're doing science, we're measuring time in seconds, okay? So we can see then that how much energy is converted in a given period of time. We can see that the units of powers are joules per second, okay? 1 joule per second is also called 1 watt. So that is the unit that we use for power, is a capital W, okay? So capital W, capital J, time obviously is a lowercase s. Watts were named after the guy who invented all of this, whose name was James Watt. So that's why it gets to call him watts. So we're going to talk about how we actually use these in calculations. If we have a 100 watt light bulb that converts 100 joules of electric energy into light every second, okay? When we want to calculate the power of a given appliance, we can do that with a simpler version of the equation above. So power is equal to energy over time. So instead of writing out the words every time, I've just written P for power, E for energy, T for time. Notice capitals, lowercase, those need to be consistent. So the energy, this is our energy. So this is 100 joules. And then every second, this means this is our time. So that's 1 second. So that's how we can get that this 100 divided by 1 is 100. And then that's measured in watts. Okay, so that's how we figured out that watt rating on that light bulb. So our second example, a light bulb converts 12,000 joules of electrical energy into light energy in 2 minutes. What's the power of the light bulb? Okay, so here's our energy. Here is our time. So this time we're gonna have to convert this to seconds and actually do some division. So we're going to set up the formula like we always do. So P equals E over T, and then we need to substitute this information in. So we can write 12,000 joules right away. Can I write 2 minutes here? No, I can't, because we always want our time to be measured in second. So we have to figure out, okay, how many seconds is in 2 minutes? So we know that 1 minute is 60 seconds, so this would be 120 seconds, and that's what we're going to plug into our formula. So we can actually do the division. So 12,000 divided by 120 is 100. We know that's joules per second, which is the same thing as 100 watts. So this light bulb has a power rating of 100 watts. So you've probably seen power ratings on light bulbs, maybe 60 watts, 100 watts, those sorts of things. So that means that it's converting more electrical energy into light every second. So the higher the power rating, the more work it's doing, okay? If we wanted to solve for energy or time instead of power using this equation, we can still do that, and we just need to use our algebra skills to rearrange. So if we start with P equals E over T, and we want to solve for E, we need to get E by itself. So right now E is being divided by T, so the opposite of that is multiply by T. They're going to cancel on this side. So energy is equal to power times time, okay? If we want to solve for T, again, we're going to start with the same thing. And if we want to get the T up top, right? We want to get T by itself. We need it first on the numerator. It can't be in the denominator. So first we need to multiply both sides by T. It's going to cancel on the right side. So then we're going to have E equals P times T. To get T by itself from here, we're going to go divide by P, divide by P. They're going to cancel. So T is equal to E over P. Okay. For these three variable equations, the temptation is to use the triangle, but please, as much as you can, actually do the rearranging. That's going to help you later on in math and science to not rely on the triangle. The triangle's not a helpful method past grade 9, so we don't love you guys using it now. The 100 watt light bulb from above consumes 3,000 joules of energy. How long did it run for in minutes? So now we can solve for the amount of time that it consumed that much energy based on its power rating. So again, I'm going to start with my formula. So T equals E divided by P. Then I'm going to substitute in, and I'm going to include my units. So E equals 30,000 joules. And then P is, this is the 100 watts from before. So we have 30,000 divided by 100 is 300, okay? And then this is joules divided by watts. We know that watts is joules per second, so the joules are going to cancel, and we're just going to be left with seconds there, right? We're looking for a time. Because the question asked for how long it ran in minutes, we need to convert this to minutes. So 300 seconds divided by, we know there's 60 seconds in a minute, is going to give us the number of minutes that this thing ran for. So 300 divided by 60 is 5 minutes. Okay, so it is more common to calculate the power of an appliance using current and voltage, which we can use a different equation for. So we might not always have the amount of energy and the amount of time that a device ran for, but we generally know how much current is going to go through a device and the voltage that's being provided to a device, because we know most of our appliances are plugged into our wall outlet, which we know the voltage of. So if we know current and voltage, we can calculate power using this equation. So P is equal to I times V. So that says power is equal to current times voltage. All right, we know that I is the symbol for current and then V is the symbol for voltage. Okay, so that's the other way that we can calculate our power. So what's the power of a hairdryer connected to a 110 volt source if it has 10 amps of current running through it? So P is equal to I times V. We're always starting with our equation that we're using. So I is 10 amps. V is 110 volts. So 10 times 110 is going to be 1,100 watts. Okay, so even though we use different units to calculate this time, because we're solving for power, it's always going to be in watts. Okay, so there's our first kind of section, and there's some practice problems associated with those. We're going to post solutions for those as well, so you don't need to worry about if you can't figure them out. We're going to post a guide. I'm going to actually cut it there, and we're going to start with paying for electrical energy in a new video, which will come up right after this one, hopefully.